First talk about independent and dependent variables. So we have something that's called a relation, and a relation just is pretty much any set of numbers. Okay, and in a relation, we have what's called the independent and the dependent variables. I don't know if you guys remember back in middle school, someone probably presented you a function machine, like on the computer, where a number went in and went boop, 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 and then came out with another number, right? So out of the x and the y, which one is considered your domain? The x, right? So let's put that in parentheses. So your x value is your domain, which means our range would be your y values. Now, do you remember the rules that make something be a function or not? What needs to happen?
Can't repeat.
Good. So for something to be a function, you cannot have repeated x values. That makes it not be a function. So our first example is function f. It's consisting of 3 ordered pairs. First thing I want us to be able to do, given this, well, I don't really know if it's function yet. It is, but we don't know that yet, is decide whether the relation is a function or not. So domain-wise, what values would be my domain? So I'm going to put a D. Yeah, so I'm going to put a D and a colon, my fancy set notation brackets.
Order -2, 1, 3.
Yeah, and you should technically write them from smallest to largest. Will I take points off if you don't? No. But try to get in the habit. So my lowest x is -2, followed by 1, followed by 3. What would be my range? Yep, so -1, 2, 4 if I go smallest to largest. Okay, so given a set of numbers, can you identify the domain? Can you identify the range? Okay, last thing we need to be able to do is decide, is it a function or not? Well, let's look at our domains. Do I have any repeated x values? No. So I'm going to say, yes, this is a function. And the reason why we said yes is there are no repeated x values, which is the rule. If I did have repeated x values, then I would say, no, it's not a function. Okay? So let's look at one that's not. Is everybody good? I'll count to 30 in my head. All right, so I'm going to skip this one because that one is a function. So let's look at H, relation H. H has the ordered pair, -4, -1, -2, 1, -2, 0.
Yeah, so you can see it with 5 years.
Yeah. So, again, let's identify domain. It's my smallest domain. -4 followed by -2. Because there are 2 -2s, I'm only going to write it once when I list my domain. My range, smallest is -1 followed by 0 followed by 1. Is this one a function? No. Function? No. Has duplicate -2s as x's. I'm just putting this up here so you have it for your notes. On the test, on your homework, you're just going to have to say no. You don't have to justify it. Okay? So, given a relation, can you find the domain and the range? Can you find the function? Whether it's a function or not. Good. Okay, so these have been in set notation. Other ways to display relations would be something that's called a mapping diagram. You remember those from last year? Something like this, where they have bubbles for your x and your y's. So over in the left bubble, I have the numbers 1, 2, 3, 4. Over in the right bubble, I have letters D, B, A. So this technically is my domain, and this is my range. Right? So my domain would be the set of numbers 1, 2, 3, 4. And my range would be what? A, B, D. We put it in alphabetical order, I guess. Okay. Is it a function? If I wrote out ordered pairs for all of that, 1 would match up with D.
The only repeats are in the
2 would match up with B. 3 would match up with A. And 4 would match up with A. So are there repeats of x's? No. So it is a function. So this would be yes. Bless you. What it would look like if it wasn't a function is you would have your split coming from, so maybe 3 is paired with both B and A. And that would make it not be a function if you have it split like that. Okay? So if you see a mapping diagram, could you find the domain? Could you find the range? Yes? All right, so now we're going to get to the good stuff, which is the graphs, which is what I really care about, is finding domain and range of actual graphs. Can I get rid of this?
Yes.
All right. Those are like elementary functions. Okay, so here we go. Here is our graph. Does anybody know what makes a V-graph? What type of function?
Not a parabola.
Not a parabola.
It's absolute.
It is absolute value. Absolute value. This would be a negative absolute value because it's flipped upside down. Okay, so go ahead and make a rough sketch of it. Do make sure that that top point is at 0, 4. The rest of it doesn't need to be anything in particular. So, here we have a graph of a relation. We need to identify the domain and the range. Unlike set notation where I had specific numbers that I could write in set notation, here I have a range of numbers, which means I'm going to have to use interval notation to write my domain and my range. Okay, so for domain, remember that's your x coordinates. So think left to right movement for x-axis, because moving to the left goes all the way to negative infinity, moving to the right goes all the way to positive infinity. Because there's arrows here, it goes on and on and on and on and on forever, so there's no stopping point in the negative infinity direction. So my left bound of my domain is negative infinity. If I go in the positive infinity direction, I have this arrow here, which is telling me that's going on and on and on and on and on forever. So it's going for a right bound to positive infinity. So my domain of this graph is all real numbers. Range, so domain, think left to right. Range, think bottom to top. So just work your way down. Is there any bottom ending point for my y? Nope, just keeps going down, right? So I'm going in negative infinity direction in my bottom of the graph. But where do I stop? Up at 4. Do I include 4? So should that be a bracket or a parenthesis? Bracket. Good. Fred?
So why is the left domain, why is that negative?
Because how do we do all real numbers again in interval notation? Negative infinity to positive infinity. Because there's no ending. This keeps going on and on and on in the negative x direction.
Well, they're both going down, so if it goes...
Right, but if I think about x-axis,
Oh, okay.
like it keeps going as that keeps going. Okay? All right, let's do another one of these. Here we have a oval or an ellipse if you want to get fancy. Again, just make a quick lazy graph of it. All we really care about are the numbers at the top and the bottom and the left and the right. So remember again, domain is left-right movement. So start from your left to go to your right. What's the furthest left point on my x-axis? -2, and we're going all the way to +2. Will there be brackets or parentheses? Brackets. Most likely it's always going to be brackets, unless there's some type of open dot on it. So my domain is going from -2 to +2. What's my range doing? Good. -5 with a bracket to +5 with a bracket. Okay. So domain and range should always be written in interval notation. Does anybody remember what test we used to decide whether a graph is a function or not?
I remember this being
Vertical line test. And what do we do with the vertical line test? Right. Draw a vertical line, and it can only intersect how many times? Once for it to be a function.
That's not a function, right?
Yes, that last one was not a function. So if you need to write that down to remind yourself, feel free. So vertical line test is when if every vertical line intersects the graph of a relation in no more than one point, then the relation is a function. So we're looking to make sure it only intersects once. If you can make a vertical line that intersects more than once, then it is no longer a function. All right, so once you get that written down, we're going to practice this.